Good day, students. Today we're going to look at the solution to your turn example 4, which is part of your D2L notes on ANOVA. That's analysis of variance, ANOVA, and this is one-way ANOVA example. All right, let's get to it. The problem reads, the administration of CNAQ wants to study the number of hours by department that instructors spend per week on their desktop computers. The manager selected 5 instructors at random from 4 of the schools. At the 0.05 level of significance, can the administration conclude there is a difference in the mean number of hours spent on computers per week by school? Of course, by instructor, right? Now, as you can see, we have the table there with the 4 different schools and the 5 random instructors and hours they've spent on their desktop computers per week. And on the right you see the F distribution chart, okay? And the F distribution, of course, is a positive distribution. So this is your F distribution over here. Now we also know in an F distribution that this area here, it's a right-tailed test only. The red area right here is the rejection area, right? It says there's a rejection region. And if we're in that region, we're going to reject the null hypothesis. Of course, the green one is where we do not reject HO, right? Or some people use the words accept HO. So do not reject HO if it's in that. And the number between the regions, right? This number right here is referred to as the critical value. So it's an F critical value. Since this is a F distribution, we call it an F critical value, so I'll call it FC. And of course this is a table, or this is one where the probability alpha, the probability of rejecting the null hypothesis, of course, is right there, and in this case alpha is 0.05. Okay, now step 1, step 2 are the same whether you use the F statistic method or you use the p-value or probability value method. And the null hypothesis for one-way ANOVA is quite simple. It is the fact that we're going to assume that the means of all of these are equal, and since there's 4 groups, we'll have 4 means. Okay, and the alternate hypothesis, of course, is quite easy as well. We're just going to say that one of these are not equal. Now H1 or HA, whatever, some books use HA, some use H1 as the alternate hypothesis, and this we state in words. We'll just say one of the means is different than the other. So one of the means is different. Okay, so that's all you need to do for your null and alternate hypothesis. Now, we're not going to say they're all not equal because one pair could be equal. We're not sure. We're just saying one of them is different than the other. So that's all one-way ANOVA does. Okay. Now step 2 is the selection of alpha, or the level of significance, and that's already done for us. It's 0.05. And step 3 is to choose the statistic. First I'm going to do it with the F statistic, and then I'll do it with the p-value. So if it's an F test, of course, the test statistic we're going to use is an F statistic, and I'll call it FC for F critical value. So how do we find the F statistic we call the critical value? Well, it's based on 2 things, and if you watched the last video, you know that it's the degrees of freedom of the numerator and the degrees of freedom of the denominator. So I'll call them DF1, DF2. Now we have a numerator denominator because an F value is considered an F ratio, the ratio of the degrees of freedom. Okay, so DF1 in this case is the number of categories, okay, subtract 1. And the number of categories in this case is 4. There's 4 different departments. So it's 4 minus 1 is, of course, that gives us 3. Okay, and in the other one we're going to look at, okay, whoops, disappeared there. There we go, we're back. And the other one, of course, is n minus k, which is the total number of observations Okay, and in this case 5 students or 5 instructors times 4 schools, that's 20 total in our sample, minus the number of categories, which is 4, so our degrees of freedom is 16. Of course, then we need to look up the value from a F statistic chart. Okay, and those charts can be found in the back of your books or in most statistical websites. Alright, so we'll have a look at that chart now. Alright, okay, let me just bring that chart in. Hold on one quick second. Alright, here it is. Alright, so there's the chart, and we're picking from this now. So let's have a look. Where are we? Okay, we have a degrees of freedom for the numerator is what? We said that was 3, so there it is right there. So in this column. And the degrees of freedom for the denominator was 20 subtract 4, which of course is 16. Okay, so there's 16. So the intersection of both of those column and rows will be our F statistic or F critical value. And it looks to be 3.24 in this case. Right? Okay, let me get rid of that now. So 3.24 is our F critical value. 3.24. So that's this value right here in your diagram. Right here. Okay? So that's 3.24. So this number here divides, right? It divides the two regions, and it's 3.24. So what is our decision rule, which is step 4? Our decision rule then is if our F test value based on the data, we haven't done that yet, is greater than F critical, which is 3.24, we're going to do what? We'll be in the rejection region, right? So we're going to reject the null hypothesis and therefore accept the alternate hypothesis. Okay, HA. So that's this region right here, right? Similar to other hypothesis testing, right? It's the same thing. So if we're in the rejection region, then we reject HO and accept HA. So let's actually do that now. Let's go find the test value. Now, I got the calculator there, so stat, we go to edit. Now you noticed I have all the data put in already to save time on the video, of course. And there they are, list 1, list 2, list 3, list 4. Now we run the ANOVA test, which is stat. Go to tests, and ANOVA is the very last one, H. And you have to tell it where the data is and how many you're testing. In this case, 4. So second function, list 1, comma, second list 2, comma, second list 3, comma, second list 4, which is above 4. Okay, enter. Now, we have an F test value, the very first number, so F test, so I'll call it FT. The test value is 7.85. We'll round to 2 places, 7.85. Now, where is that? So let's do our final conclusion now. 7.85 is going to be up here in this area right here, isn't it? Okay, so 7.85 is somewhere in the rejection area, and therefore we're going to reject the null hypothesis, right? 7.85 is definitely greater than 3.24. Therefore, reject HO and accept HA. And let's see what a HA means. HA means what again? Alternate hypothesis. H1 is that one of the means is different from the other. Okay? So can the administration conclude there is a difference in the mean number of hours? Yes, he can. Okay? So therefore, one of the means is different than the other. So there is a difference in the means. Okay? Now, I did this one based on the F statistic. Okay? Is different from the others. Now, when you use the p-value test, you turn a 5-step process basically to 4 steps. Okay? Now, if I did this problem based on p-value, basically step 3 disappears. Okay? Step 3 disappears. So let's get rid of step 3. And if I do that, I really don't need the F distribution either, so I can get rid of that. So it does save time. Okay? Now, therefore, I don't need this step right here. So basically, I'm skipping step 5. Right? So I'm down to 4 steps. Now, if I mute, I can get rid of all this too. Okay, I'm going to leave the conclusion because the conclusion's the same. No matter what test we use, you get the same conclusion if you do it correctly. All right, but all we do in step 3 now is if we choose to do the p-value test, then you'll just write down the p-value, which if I go back to the calculator, you see it there, 0.0019. 0019. And then do your conclusion based on the p-value. And we know that if p is less than alpha, then we do what? We do this. Yes, that's right. Reject HO and accept HA. So let's see if our p-value, what's our p-value? 0.0019. Is that less than alpha, which is 0.05? Yes, indeed, it is true. Therefore, we reject HO and accept HA. Therefore, one of the means is different from the others. So it's the same conclusion, a much shorter process. A lot of people prefer the p-value test versus the F statistic test or F critical value. Now, on the calculator as well, just to double check before we leave you, is let's just check our degrees of freedom. You notice the first one, in the first factor, the degrees of freedom is 3, and the degree of freedom is 16, which is what we both calculated, right? So you can double check your degrees of freedom on the calculator as well. So there's your conclusion using both tests. Hopefully this video helps. That's it for now.